Hello there, and welcome to Practice 42. In this video, we are going to continue working with volume. This is volume of composed figures. When I was in school, I learned these as irregular figures. Composite figures is another name for these. So these are volumes that have bizarre shapes. If you look at all these shapes, they are irregular shapes. They're not just cubes or boxes. They have some weird shape to them. So I suspect I'm going to need some paper for this one. And you might want to get yourself some scrap paper too. I've got a piece. I just need to pull it down here. And that's going to sit maybe right there. So let me make a couple of copies of that so I have it ready to go, because this is going to need some space. And let's look at this first problem. It tells me to use the formulas that we've been using. Same thing we did in the last lesson, so we know those are available. And then here's number 1. It says a cube with edges of 2 centimeters is attached to the top of a rectangular prism that is 9 centimeters long, 4 centimeters wide, and 3 centimeters tall. What is the volume of the composed figure? So I'm going to come to my scrap paper and I'm going to draw a model of this for you. So the first thing that we want to do is draw a cube. Let me get a little bit more ink going here. And that is definitely not a cube. Let me draw it large and then I'll shrink it down. So as close as you can, draw a square, because cubes are perfect squares that are put together. So I'm going to copy this one, paste it. Well, gosh, let's try it this way. I'm still getting used to this slightly different iPad. It's amazing how much a little bit of difference can cause when you're trying to do these. So here is the connection of vertices, and there is something resembling a cube. So this cube, it tells me in the problem, is 2 centimeters. So that means that all dimensions are 2 centimeters. And I'm going to resize this if it will allow me to. It does. So that is sitting on top of a rectangular prism. And that is a box, if you will. So this is the other part of the composite shape. I thought about going ahead and drawing these before I met with you, but then I thought maybe you would like to draw them too, so I didn't do that. Okay, so here is the rectangular prism that is 9 centimeters long, 4 centimeters wide, and 3 centimeters tall. So for some reason, they have attached these two shapes. They have put the two shapes together. That's addition. So we're attaching them somehow like that. So let's do the volume of each one. The volume of this one is length times width times height. So 2 times 2 times 2, that's 2 to the 3rd power. Use your calculator. That is 8 centimeters cubed. And one thing I did mentally, but I forgot to show you, is to make sure that your units are the same. All of them are centimeters. They have to be, or we can't make this work. Okay, the volume of the rectangular prism is length times width times height. So we have 9 times 4 times 3, and that is, I believe, 108 cubic centimeters. And then we need to put those together. So 108 plus 8 is 116 cubic centimeters. So the answer to number 1 is C. If you don't have a shape, I recommend drawing a shape. Okay, number 2 says, what is the volume of this solid? So let me put some dimensions on here. I'm going to look at this as, let me think. I'm going to look at this as 2 separate shapes. The first one, I'm going to count right here as this red one. And I'll try to highlight it for you so you can see what I'm doing there. But I'm looking at this box that's on top. And let me see if I can get a highlighter going that will allow you to follow. Yes, this is what I was hoping for. So if you look at this red one that I'm coloring right now, visualize this box sitting on another box. They're joined together, just like the ones we just looked at in problem 1. So there's this red box that I've made red, and then the gray box I'll leave down there at the bottom. But the red one, let's figure out the length of the red one. The length is going to be 4 units. The width is 2 units. And the height is 2 units. So let's calculate the volume. Volume is length times width times height. So volume is 4 times 2 times 2. That is 16 cubic units. Think of sugar cubes. 16 sugar cubes. Then for this gray one, we have a length of 4, a width of 4, and a height of 1. So let's calculate the volume of this one. Length, width, and height. 4, 4, and 1. So the volume is 16 cubic units. And they're connected, so we put those two together. We have 16 and 16. I'm liking B on this one for 32 cubic units. Number 3, we have the same scenario. I have this box here that is attached to another box that I will just leave uncolored. But I encourage you, if you can write in your book, some teachers ask that you not write in the book, so please do what they ask you. But if you can, color it in, and that will help you see the difference between these two. So the volume of this part, remember length, width, and height, is 4, 3, and 1. So that is 12 cubic meters. And then the the volume of this other one, we have length, width, and height. So the length looks like, I'm going to call it 1. The height is 4. That's pretty easy to see. But it's that width that we don't know. So let me zoom in here and show you where I'm getting the width. The width is from this point to this point. So if I really make that dark, it's probably better that I highlight it. You can see that that line is going to be 3. It's the same as the line over here. So here is a 3 meters, and I'm going to use that as my width. The two shapes are sharing that line. So this one is also 12 cubic meters. And if you combine the two, 12 and 12, make 24 cubic meters for this volume. So number 3 is A. Number 4. Macy attaches 2 cardboard boxes together. One box is 12 inches long, 8 inches wide, and 4 inches tall. The other box is 7 inches long, 3 inches wide, and 3 inches tall. What is the volume of the composed figure? So I'm not going to draw this. I'm just going to use the information that they gave me. One box is 12 inches long, 8 inches wide, and 4 inches tall. I am going to use my calculator on this one. I don't trust myself on those big numbers. I don't really trust myself on the little numbers because I don't do math well in my head. So 12 times 8, that's 96, times 4 is 384 cubic inches. And then for the green highlight, I have volume is length, width, and height. We have 7 long, 3 wide, and 3 high. So volume is 63 on that one. Let me be sure. And then when I add those together to get the composite, I come up with 447 cubic inches. So on that one, you just have to do your volume formula twice. Number 5, what is the volume of this solid? Now, let me go ahead and do a little bit of drawing. I'm going to put in a line, an imaginary line. So I'm going to make it a dashed line. Anytime you want to show an imaginary line, use a dash, and that indicates that it's not really there, but it's there for my brain to sort of understand the problem a little better. So I have this tall box over here on the side, or maybe this is a chair. This is the back of the chair. And then I have this part that I won't color. So let's look at the volume of this one first. Length, width, and height. So here the length is from here to here. Be very careful because that's not what we want it to be, right? They're telling me that from that dot to that one is 7 feet, but I don't want to go from that dot to that one. I only want to go from that dot here. So I know that this is 1 foot. So if that's 1 foot, that means that this is 6 feet. Because together, those make that 7. So you have to be really careful right there that you're not using the 7. So the long side is 6, the width is 2, and the height is 3 on this one. So that's going to give us 36 cubic feet for this part. Then on the yellow part, we want volume is length, width, and height. Be careful again. From this point to this point is 3. But we need to take into account that imaginary line also. Now, we do have that in terms of the height. You know that 6 feet is the height, so this would also have to equal 6 feet. That's probably the easier way to see it. But my dashed line is 3 feet, making a total of 6. So I can tell you the height of this yellow one is going to be 6. I can tell you the width is 1. But I need to know the width. And the width is this line right here. Let me make it green so you can see it. The width is going to be this one, right down here. And I can tell you that one because I know this one up here is 2. So this line is also 2 feet. So you have to figure out the missing pieces on this one. And this is not easy to do for me. I always had trouble with these in school. So that's 12 cubic feet. You combine that with the 36 cubic feet. So for number 5, I'm liking B. 48 cubic feet. Number 6. A microwave is on top of a refrigerator. Both are rectangular prisms. The refrigerator is 3 feet long, 3 feet wide, and 5 feet tall. The microwave is 2 feet long, 1 foot wide, and 1 foot tall. What is the volume of the refrigerator and microwave together? So there's the addition word. I'm not going to draw them. You can if you want to. But here's the fridge. It is 3 by 3 by 5. So that, let me put the formula in. I'm really getting bad about that, not writing it down. So that's going to be 30 cubic feet. Then the microwave, length, width, and height, is 2 by 1 by 1. So that is 2 cubic feet. Put those two together, and I've done something wrong. I can't multiply. I told you, I don't trust myself. 3 times 3 times 5 is not 30. 3 times 3 is 9, and 9 times 5 is 45. That's what I get for doing this in my head. So 45 plus 2 is 47. Thank goodness 32 wasn't one of my choices, or I would have missed it. But for number 6, I like B, as in boy. Number 7. What is the volume of this solid? So I'm going to go ahead and draw that imaginary line again, right here, to separate those out. And let me color one of them for you. I think I'll do it in green because I can do green ink. So here is, this is another chair lying on its side maybe, if that helps visualize it that way. And I'll fix the coloring here in just a second. It's easier for me to come back and erase than it is to try to get in the lines. So there's the green part. And let me clean that up just a little. I am not an art student. Okay, that's close enough, guys. I'm not going to take all day to get that right. Okay, so we have this chair, or whatever you want to think of it as, lying on its side. Be careful right here, because this whole dimension is 7 centimeters. We don't want to go that far. We want to stop right there. So if this dimension, according to this bottom number, is 2 centimeters, then this is going to be 5 for the green part, because 5 plus 2 is the 7 that I crossed out. So we should be good to go here. I have length, width, and height, 5 long, 2 wide, 6 high. That's going to be 60 cubic centimeters. And then on this part, we have length, width, and height. So we have, I'm missing something. Oh, this dimension, the height, right here. I told you guys I struggle with these. I really have to pay attention to what I'm doing. So I need to know the height on this one. I know the length is 8. I know the width is 2. And the height, that's going to match up with this line right here. So that's going to be another 6 centimeters. And then when you multiply that, I'm going to have 8 times 2 times 6 is 96 cubic centimeters. And then you put the 96 and the 60 together, and that is 156 cubic centimeters. So for number 7, let me check it before. Yes, C is the answer. Number 8. I haven't needed all this paper. I thought I would. A rectangular closet is attached to a rectangular room. The room is 10 feet long, 12 feet wide, and 8 feet high. The closet is 5 feet long, 3 feet wide, and 8 feet high. What is the volume of the room and, there's your addition word, the closet? So the room is 10 by 12 by 8. I believe that's 960, but let me be sure. Yes. And then the closet is 5 by 3 by 8. And that's 120. Then 960 plus 120 is 1080. So for number 8, I'm liking option C. Number 9. What is the volume of this solid? So I'm going to put my dashed line in right there to separate these two out. And this one I will color red. There are other ways you can divide these up. However your brain sees it is the way to go. But this is just what my eye sees when I look at this. We've got this tower sitting on a base. So for the tower, that's the red part, volume is length times width times height. And I can tell you the width is 3 and the height is 6. But we got to come up with the length, which is that dashed line. No, we know that. Sorry. We need to come up with this line right here. Right there is what I'm looking for. Okay. And I can find that right down here. Just look for another one like it. Here it is. That 5 is matching up to that one. So I'm going to say this is 5 inches. And that's the missing dimension. So then I'll say 5 times 3 is 15 times 6 is 90 cubic inches. That's for the tower part. Then down here on the bottom, this one's pretty straightforward. I have V equals LWH. So it's 11 long, 5 wide, and 3 high. 11 times 5 times 3 is 165. And 165 plus 90 is 255. So for number 9, I believe it's D, but let me double check. Yes, it is. 255 cubic inches. Number 10. The main office building is in the shape of a rectangular prism and is 10 meters long, 6 meters wide, and 6 meters high. A rectangular prism addition, there's the addition word, is 3 meters long, 3 meters wide, and 6 meters high. What is the volume of the main building and the addition? So they're saying find the two dimensions and then add them together. So the main office is a rectangular prism. That gives me the formula. That is 10 by 6 by 6. And I believe that's 360, but let me be sure. Yes. And then the addition is 3 by 3 by 6. And that is 3 by 3 by 6, 54. Add that to the 360, and the combined volume is D, 414 for number 10. Number 11. What is the volume of this solid? This is kind of like the microwave on top of the fridge kind of thing, only these are centimeters, so this is not a microwave. Centimeters, they're roughly 2.5 centimeters per inch. So this may be Legos, it may be a kid's toy of some kind, much smaller scale, but it's the same idea. So for this one, I have volume is length, width, and height. I know the length, and I know the height. What I do not know at the moment is this dimension right here. Right there. We need to figure that one out. So if you find one that is comparable to it, there it is down here again, it's 5. So I'm going to bring up the 5 centimeters to go right here, which puts it right there in my formula. And I believe this is 480. And I am wrong, majorly wrong, of course. It's 240. Pays to check it if you're me. And then down here, I can tell you this one pretty straightforward. The length is 10. The width is 5. And the height is 6. I think that one's 300. Then I need to join them together. So 240 plus 300, you've got it, is 540. So this is number 11. The answer is A. Okay, number 12. Two cabinets are attached together. There's addition. The cabinet on the left is 2 feet long, 4 feet high, and 1 foot wide. The cabinet on the right is 3 feet long, 2 feet high, and 1 foot wide. What is the volume of both, there's another addition word, of both cabinets? So here is the left cabinet that I highlighted in yellow. 2 by 4 by 1. I can do this one in my head. That's going to be 8 cubic feet. And then the green one is 3 by 2 by 1. So that's going to be 6 cubic feet. And both of them together is 14 cubic feet. Number 12 is A. Number 13. This one kind of looks like a stage, maybe. But we need to find the volume of this solid. And I'm going to let my dotted line, the imaginary line, be right there. Let me try that again. That is not straight. That's not much better, but that's okay. We'll put it right there. And then I'm going to color in part of this. I'll color this smaller one. So we need to find this little portion and then that back portion and put those together. This one's pretty straightforward. I have let me put 3 pockets and then we'll fill them in. So long 6, wide 4, high 2. I believe that's 48, but I'm not taking a chance the way I'm going. Yes, 48 cubic inches for the green. Be careful back here. Length, width, and height. It's 15 long. It is 11 wide. And it's 2 inches high. The height is the same throughout. And this is not a stage because these are in inches. I'm not sure what this is, but it is definitely not something I can stand on because at most it's about 1.5 feet on the largest dimension. But that's okay. We don't have to know what it is. We just have to be able to calculate its volume. 15 times 11 times 2 is 330. And 330 plus 48, I'm liking a 378. So I believe it's B for number 13. And it is. I'm checking these as we go. Two books are stacked on a table. The bottom book is 22 centimeters long, 15 centimeters wide, and 3 centimeters high. The top book is 20 centimeters long, 13 centimeters wide, and 2 centimeters high. What is the total volume of the books? So I'm not going to draw these. The green one is 22, 15, and 3. No way I'm going to attempt that in my head. I do know people, I have friends who can do that. 990. But I am not one of those people. I don't do mental math well. So 20, 13, and 2. Um, 20 times 13 times 2 is 520. Add that to the 990, and you've got it. 1,510 cubic centimeters. And that is number 14. Answer is D, as in dog. Number 15. This one looks like maybe it is a runway at the Miss America pageant or a fashion show. I don't really know what it is. And again, it doesn't matter what it is. But here is the imaginary line. And I'm going to let this be one of my shapes. And then I won't bother to color the other one. If you really like the colors, you can color them both. I'm just not going to waste your time sitting here coloring, even though I like to color very much. All right, so this green one looks like I know 2 of the dimensions very clearly. I know the 16 is the length, the 8 is the width. I need to figure out the height. And I bet you already know it. If this is 7 feet over here, then this is 7 feet over here. Because if they're not the same height, we would be able to see that. So the height is 7. And here comes the math. 16 times 8 times 7 is 896 cubic feet. Then this one, volume is length times width times height. Length is 20. Width is 10. And height is 7. So we're going to multiply 20 times 10 times 7, and that's 1,400. Plus 896 is 2296 cubic feet. So for number 15, I'm going to go with C. Number 16. 2 boxes of cereal are next to one another. The box on the left is 10 inches long, 2 inches wide, and 14 inches high. The box on the right is 12 inches long, 3 inches wide, and 15 inches high. What is the volume of both boxes? There's the addition word, both. So the box on the left is 10, 2, and 14. I believe it's 280, but I wouldn't swear to it. So let's see. Yes. The one on the bottom, or sorry, the right, the yellow highlight, is 12 by 3 by 15. And I have no idea what that is. I think that's 540. added the 280 to get 820. So for number 16, I like option B. Alrighty, that brings us to the end of volume. And I didn't need all that scrap paper. I'll use it on another problem. But this is pretty complicated stuff. If you have questions about it, please contact your instructor. He or she can help you with more examples of these. And in our next lesson, you and I will start looking at angles and degrees, one of my favorite things. So I'll see you soon, and I hope you have a really good day. Bye-bye.